This gets us directly towards our homework. I want you to build a tool called Bonsaikon for bonsai daikon or tiny daikon. The idea is to take a number of executions like these and produce assertions, that is invariants, that hold for all runs observed. For the starting point, all I want from you is ranges of variables as you have seen them. What Bonsaikon should produce is a range of variable values seen at the call and at the return of each function. Here's an example for square root, how this should look like. At the call of the square root function, x is always between 2 and 16, and the variable epsilon is always 10 to the power of minus 7. And as you can see, I want you to output these ranges, and if the range has just one value, then I want this to be an equal sign. I want you to output these as assertions that can be inserted immediately into the code. This would be preconditions that hold when a function is called, but I also want you to report postconditions that hold when the function returns. Here we have the range for the variable y at the end of square root, and also the return value, which I gave this special name ret. Return value is between square root of 2 and square root of 16, as seen for these 3 runs. The question is, how do you get these ranges? The answer to that, again, is our tracing function, which allows us to record the state of the program at every call and at every return. What you set up is a special traceIt function, which gets the current frame that's executed, the event that's taken place, and an argument. Let's first take a look at the event. The event is either call or return and translates directly into these 2 situations you'd like to monitor. The current frame tells you which code is being executed. Frame.f_code.co_name gives you the name of the function that's executed. In our case, that would be square root. The frame.f_locals attribute is a dictionary that gives you access to all local variables, such as y or x or eps. And finally, if the event is return, the argument that's passed over here gives you the return value. So what you do is, you run your program with the trace function enabled, you record the call and return events, you check for every single function that's being called and its calls and its returns, you check all the variables through frame.f_locals, and over time you record the ranges. When the execution is done, you output the ranges that you have observed. So in the beginning, first run, square root of 2, x is just 2, then x is between 2 and 4, and then x is between 2 and 16. Likewise for y, where the square root gets expanded over time. Likewise for the return value, where again the range of return values extends as more and more runs are observed.